So, who here knows what this movie is? All right, I'm going to address the big question first, which is, what is it? Um, so, this is a movie, the theme of this talk, in some sense, is taken from this movie. It's one of my favorite movies, My Cousin Vinny. I'm confident many of you have not seen it, and so this is a mistake that you should rectify. And if there's only one thing you take from this talk, I want it to be that, okay? It's more important than most of what I have to say. All right, so let me start with this. Who am I? I'm Nico Matsakis. I am, if I'm not mistaken, I might be mistaken, but I don't think so, longest serving Rust maintainer. I've been working on it since 2011. My daughter was 3 months old, now she's in high school. That's kind of weird. I used to have cool pictures by her, but she stopped thinking that was cool when she got out of kindergarten, so sadly you'll have to make do with memes. I am the co-lead of the Rust language design team. The borrow checker is my fault, for better or worse, and I am a senior principal engineer at Amazon, where I basically just get work on Rust all day, since people often ask. But the cool thing about that job, what I do quite like about it, is that I get a chance to see Rust development happening from the inside, right? I get to see all the stuff happening at Amazon, as well as, I see a lot of other companies too, in general, but I feel like there's a difference when you're inside, right? And what I see, both based on that and what I see elsewhere, is that Rust is soaring right now. We're stronger than we've ever been. We're doing all kinds of crazy things. Foundational software across the map is being rewritten in Rust, and I think you can see it if you just look at the platinum members of the Rust Foundation. I don't know if we have any Rust Foundation people here today, besides myself, but okay. But you can just see it right here, right, just on this list. You can see that we're running a lot of stuff in the internet. We've got AWS, of course, I just talked about that. S3, EC2, CloudFront. There are people from all those services here, I think, you name it. It's using some Rust somewhere. Microsoft using it for Azure. Last RustConf, there was a great talk by Mark Rusinovich. I recommend it, about all the different uses they have. Companies like Meta that run huge clouds are also investing heavily in Rust. So it's really cool. Of course, Rust is used in Linux. You can see this new gold sponsor. We're very excited. Canonical. I don't know, they're the ones who make Ubuntu, if you don't know. And they're doing a lot of work porting all their utilities and things to Rust, so that's super cool. Of course, Android, got Alice here, working big on Rust for Linux, which is now no longer experimental. It is now stable. You can write Rust if you can get your maintainer to approve the patch, I guess. So that's super cool. And that's where we come in with this Google, We've got a lot of usage in Rust in the foundational layers of Android, which there's some excellent blog posts that I really love talking about the impact of that, showing these nice little graphs with the amount of memory on safe code and the amount of vulnerabilities sort of falling in free fall, much like the last talk, Andrew, where you had those things with the same shape. You're like, okay. Anyway, so that's all super cool, and what I have to say is it wasn't always like this. If you remember, and some of you probably do, Rust 1.0, I'm doing a little bit of reminiscing a la Carl, I guess. Well, 2015, that's when we had the first 1.0 release. And what I remember is that we had a lot of ambition. We were super psyched, but there was so much work to do, and we didn't really have a lot of production users. We had Dropbox. They had done something. We were super psyched about that. I probably shouldn't say this, but actually what they did was move away from AWS onto their own home-built system, which they did in Rust, save themselves a bunch of money. Never mind. Anyway, so it was cool, right? We were super excited, but also Go and Swift had announced themselves a year or two earlier, and they had these huge conferences with tons of people, and it was kind of are we ever gonna be able to do that? Can we compete with these languages that are backed by big foundations? How are we gonna pull that off? And okay, this is a bit of a stretch, but this made me think of My Cousin Vinny. And I'll tell you why. Because there's a scene, so in this movie, he is up against, his cousin has been accused of murder. He's facing a criminal trial. If Vinny screws it up, his cousin will die. And he's at some point, he thinks this is all fun and games for him. He's I'm gonna get on trial. And then he gets in the thing and he realizes, oh my God, if I mess this up, my cousin is gonna die. And he's getting scared. And he talks to the star of the show, Mona.
Bet I could, huh?
You know what I think?
What?
Honestly? I think that once you're out there and you're doing your thing out there, I think you're gonna be really great. Really great.
Who wouldn't want to hear that, right? That's like empathy is super good. For us, that moment, that like Mona moment, was the Stack Overflow survey of 2016, where we went from being number 3 or something to being the #1 most loved language, best headline of all time, which a title which we have retained to this day, although they changed it from most loved to most admired, for which I will not forgive them at any point. But that's okay. You have to understand what most loved means, though. It means the highest percentage of people who use the language want to keep using it, right? So we could have 10 users of whom 3 or 8 still want to use it, and we would win this metric. So it did not mean that we were the most popular by any means, but there was something we had, something that people liked, right? And that was really cool, and that was very rewarding, and I think kind of what kept us going. And when you ask yourself that question, well, what is it that people like, actually? What is that thing that keeps pulling you in? You might think, and I think I used to think, it's all the headline stuff. It's like, hey, it's the cool no garbage collector. And I think that's not wrong, but it's not right, right? I mean, it's all important. Like, not having a garbage collector is the reason tight tail latency, low memory usage. It's the reason that people in the cloud service, it's the reason AWS, it's the reason all these folks are coming who are building network services, like most of you here probably, right? Tight tail latency, low memory usage. No mandatory runtime is the reason we can use it in the kernel. No undefined behavior, that's the reason Canonical is so into it, with all like trying to get sudo to not, to be more memory safe and so on. But that's what brings the people in the door, but I don't think it's what keeps them in the room, And actually, Carl once said it to me this way. I thought it was pretty accurate. He said, like, people think they come for the performance, but they stay for the enums. And we did this series of interviews called the Rust Vision Doc. I'll be showing you quotes as I go. But Carl, you were more right than you know, because literally enums came up in like more than any other word. Like if I did like a word cloud of things people like about Rust, enums was like, so, cool. We stole them from Haskell and OCaml, but that's okay. You don't have to know that. We invented them. Algebraic data types, great innovation, thank you. Anyway, I think more generally, it's not just enums, right? What we hear a lot is it's actually reliability. It's actually reliability and versatility, right? Because I think what most people have happen is that they think, this Rust thing's gonna be kind of hard and annoying to use. It's gonna take me a while, but once I get over the learning curve, I can do the hardest part of my system in it, and it will work well, and I'll just use, whatever. I'll use some other language for the rest, and that'll be fine. That's a good trade-off. That's where a lot of people start, but it's usually not where they end, because once they get used to Rust, they start finding, actually, it's a little more verbose perhaps in some places, or makes me say some things I wish I didn't have to say, but all things considered, it's pretty decent, even for the high-end stuff. And it's nice to have everything in one language, right? And it's actually cool that Mark is in the audience. Hi, Mark Bose. He and I wrote this blog post some time ago that kind of makes the case, talking about Aurora DSQL, where if you read the post, you'll see the team is now, or the product, the service is now written 100% Rust. Is that still true? Okay, good. But it wasn't always like that. It started out with just the data plane in Rust. Actually, it started in Kotlin, but they moved it to Rust, and then they thought the control plane should stay in Kotlin, and the Postgres extensions in C, so 3 different languages. But over time, they realized, no, actually, we should use Rust for all of those, right? And they moved it, and things are working better, and I think they're even using it for their web pages, the internal web pages, and so on, so it's pretty cool. I took 2 lessons. Whoa, oopsie, my bad. Where was I? No, don't look. Okay, good. I took 2 lessons. I think the foundations of Rust are really solid, and I think we're delivering something that's good enough, but we have to keep our eye on, we have to cover that whole span. It's not enough to just do the low-level stuff. You have to be usable for everything, so. The thing is, the pitch for Rust traditionally has been a little tricky. It's kind of an eat your vegetables pitch. It's like, yeah, it's gonna take some time to learn Rust, but it's worth it. You just got to put in the effort. You'll see. You'll like it. Join us. So the idea is it's going to help you level up, right? You're going to be more clever. You're going to learn cool things. You're going to get more done, and you're going to feel better about yourself and the work you do. I think there's a lot of truth to that, but most people are not interested in this kind of delayed reward. Right? They'd rather get the benefits up front. And I think the pitch changes a little when you have a team. It's more like, hey, you're experienced, but you'll be able to help your less experienced people onboard and get up to speed faster. You won't have to worry so much about what they do. They can earn their train. Let the compiler take them through the training wheels. And I think that's all true too. What I think is really interesting though is that whole thing, that whole trade-off is about to change, right? And Carl said it already. That what we're seeing is that AI agents are actually just really changing this trade-off quite a lot. And of course, unless you've been under a rock or something, you have probably heard about AI. I know I've talked to I think literally everybody here about it probably at some point. But I feel like we're hearing a lot, most of which is nonsense. Like some people saying, oh my God, there will never be any coding anymore. I don't think that is true. I also don't think AI is useless or all hype. I think it's really powerful and really useful for a lot of stuff. It also makes a ton of mistakes, and it takes a while, kind of like Rust actually, to learn how to use it well, but that when you do, it is very powerful, right? And I think one of the weird things about it is it kind of turns our expectations upside down. I feel like I keep doing this myself and hearing other people do it, where you're kind of used to thinking of computers as really good at math and people as really good at ambiguous stuff. But LLMs are really bad at math. I mean, well, they're actually not that bad, but they do it in the most expensive, inefficient possible, weirdest possible way, right? But they're actually pretty good at ambiguous problems. So it's kind of like we asked for a smart computer and we got a sort of inexperienced, arrogant human, which, like, it wasn't maybe what you wanted, but it is maybe what you can use. I don't know if you need it. So they can be really effective, right? And the interesting thing, of course, is we go back to that quote, like, I feel a lot safer with less experienced engineers contributing. Well, my version is I feel a lot safer with coding agents contributing to critical applications when they have guardrails and safeguards to help them along, right? And you don't have to take it from me or Carl, because, hold on, I'm letting this person take a picture. Okay, good. Because we're not the only ones saying it, so is the founder and co-president, or founder and president of OpenAI, wrote this tweet, which I always thought was kind of cool. Rust is a perfect language for agents. Anyway, so all this is to say, I'm not actually going to talk about AI this whole talk, don't worry. But I do believe AI is coming, and I think we have to be ready, right? Whatever you think about it, it's going to change a lot of stuff. And that brings us back to my cousin Vinny. So Marissa gave Vinny that reassuring speech, you're going to be really great. And then she said this.
If you don't fuck up.
Yeah. So that's where I think we find ourselves, if we don't screw up. So here's the thing. We're kind of at this phase change moment, right? Ever since I read this book, everyone reads this book, the one, what's it called? Crossing the Chasm. It makes sense. This has explained some things to me. It's a useful model with basically different phases of adoption, right? And I've kind of been wondering, well, where's Rust in here? And I think the answer is very variable, but it's somewhere around moving from early adopters to early majority, I would have said a year or two ago. Definitely meaning going from people who are using Rust because they want to do cool new things, that's sort of early adopters, to people who are using it because, well, even though they don't like doing cool new things and they want to get their job done, but it makes sense actually, so they're using it. And what I think is AI is basically just giving us a big shove. To the extent that we were just pulling ourselves out of the chasm, we're now just got catapulted, ready or not, right into the early majority, and we have to make the best of it. So the good news is that's super, well, the bad news is we have some challenges to overcome, and we have a group of people using Rust who are probably less tolerant of its quirks because they weren't here for the love of Rust, they were here to get some stuff done. And the good news is we have a lot of opportunity, right? So what are some of the challenges? This is not an exhaustive list, but these are the ones I'm going to talk about today. You may be familiar with some of them. Let's just start right in. The async experience. How many here use async Rust? Okay, good. This is a perfect time. So, async has become, actually this is TokioConf, so I knew all of you would raise your hands, However, even in a regular Rust conference, I would have pretty high level of confidence that most of you would raise your hands, because when we ask in the survey, async is like 50 to 80% of respondents, I don't know, it's very high, are using it to build network services and things like that. And then the reason that async has taken off, in part, both because it's a great fit for Rust, but also because it actually is used in many different areas with very different requirements, right? So we've got sort of network services that process, it could be a really high-end one that processes tons of messages. It could be lower ones that do control planes or things that handle 1 or 2 messages every once in a while, but either way, it's a good fit for those. Then you have things like the embedded sensor nodes or whatever that don't even have an operating system, and actually async Rust can work on those too and give you a higher level abstraction, so that's really cool. And part of how we manage that, of course, is we don't bake in very much. Right? The language feature is quite minimal, and the runtime makes most of those trade-offs. And so Tokyo is super optimized for more of the server sort of environment, and other ones like Embassy or what have you are often more popular for the lower level embedded stuff, right? And that's kind of in contrast to, say, Go or Swift or Java or something, which ships a kind of complete standard library that has all that stuff baked in. So that's cool. But, so async Rust is really popular, but of course, let's face it, it can be kind of hard. This is one of my favorite quotes, came out of those Rust Vision Doc interviews, where this guy said, you basically have to be some sort of Rust god to even understand this code that uses generics and asyncs and whatever. And I just love that. So it's kind of true in some ways if you're going into the really deep end, right? But I think there's also just a lot of stuff, we've seen it come in the talks today, you know, things like cancellation safety and async drop, and how do I figure out my deadlocks or my future locks? Why are these weird latency spikes? And we've heard some answers on how you can deal with it, but these are the kind of challenges that I feel like Rust is supposed to protect you from, the sort of if it compiles, it works, and we don't always in this environment. And that's too bad, right? I'd like to do better on that. And maybe you're thinking, well, I thought AI agents were gonna change everything. Like, don't they help with this? The answer is sort of, but remember, they're kind of like inexperienced, mediocre, arrogant humans, so they will actually, the same kind of mistakes that you can make, they can make too. Like if the guardrails aren't protecting you, they're not protecting your agent either. So that's the problem. So what do we want it to be like? I mean, I think we want it to be basically just add async, right? You should learn Rust. You have your sync Rust, and if you want to make it async, well, you just kind of have to sprinkle in async and await here and there, and you know that things will basically work the same. That may not be what you actually want. You may want it to work differently, more efficient, more concurrent, but you can get from A to B and it basically works in a consistent way, in a simple way, and then expand it. But that's not where we're at, right? Where we're at, actually, there's a lot of places you might want to use async or await that you can't today, where you can only use synchronous functions. Right, so we support inherent and top-level functions. We support static dispatch on traits, but we don't support dynamic dispatch. We have some other limitations there. We have these interops, and we don't have drop, and so on, right? So we have to get down this list if we really want to achieve that just add async promise. And you might wonder, well, what's taking so long? Why is that hard? Well, remember I said how awesome it was that we could cover this whole big space and cover all these requirements? Well, that makes it also very hard to build these fundamental language features that can scale to all those requirements. And it would be much easier if we could just target a subset of this, right? So let me give you an example to kind of illustrate what I'm talking about, async functions in trait. This is something you can do unstable. So you can have a message processor trait. It has an async function. This case, I'm saying like takes a message and processes it, I guess. And I'm saying there's two impulse, processor 1 and processor 2, okay, and they do different things. Now, when you call this in a generic context, like I have some type P, which is a message processor, and I'm gonna call it. Well, when the compiler goes to compile that code, it's gonna make multiple copies for every type that you use it with. That's called monomorphization. So that means when we're making that particular copy, we know exactly what code you're gonna call. We know if you have processor 1, or we know if you have processor 2, and we can specialize it to that particular impl, which means we can allocate enough stack space and other stuff. So this works just fine. This works unstable today. That's great. Oh wait, I had things. Darn it. Okay, there you go. I have to remember. But what about this? What about when you call with din? So in Rust, when you call with din, you get one copy of the function, no matter how many types there are. So which means we don't know at the time we generate the code how much stack space you need or anything else. So we won't compile this, right? We can't compile this in the naive way. Now, some of you are thinking, oh, well, I've used the async trait crate. That sort of solved this problem. Why can't we just do whatever they do? Well, this is what they do. They modify the trait to introduce a box, which means a heap allocation, more or less like this. The problem with that, I mean, that works, but it's not really going to work in all of these environments that I was talking about. You can mostly use it in the server space, but when you get to kernels or embedded, it's a non-starter. And if I'm going to be honest with you, I would say we've kind of stalled out on progress here, which I hate to say. I remember Carl asking me some years back, we're going to get async functions and traits, right, Nico? And I was like, oh yeah, heck yeah. It was like 2022 or something. I don't know, here's a blog post from 2021 where I'm talking about it. That's bad. That's not great. So I think we're kind of stuck in this catch-22. You know, we want a system that's simple enough, like I said, that it can scale up and be versatile all the way up to the high-end stuff, but we also want it to scale down, and that's proving difficult. It's kind of like this, right? I was super into this picture. Anyway, hard choices, right? And I think we've been a little stuck on this, and I would like us to get unstuck. So what I think we should do, and what I'm proposing around this year and hoping to see progress on, is, well, you know, it's kind of the Rust way. Do both. We'll find a way around. We'll make them both work, but do both in a particular way, right? Take these two tracks, and I've called them just add async and beyond the ampersand. These are roadmaps. I'm going to come back to this topic later, but let's see if I click on what happens. Okay. Yeah. So you can actually go browse these on the Rust project goals repo. We have a whole bunch of them. You can see them over here, the roadmaps. These are like some of our plans, the things we're trying to do, right? And so just add async outlines, let me scroll down here, a set of steps we can take over the next couple of years to get to that goal that I was talking about, right? There we go. Beyond the ampersand is similar, but for the purposes of really expanding our fundamental capabilities. And what I think is interesting is there's this old trade-off that we're wrestling with. We're, you know, like us, like many who come before us, are wrestling with what is the right way to do a minimum viable product anyway, right? And the usual answer is, you should do this vertical slice, right? Make it work well for some set of users all the way through. Don't try to make it meet all the requirements first and then go up from there, because you'll never get there. And I think that's right, but I think what we found is you kind of have to do a little bit of both, because it's really hard to have confidence that your design is going to work for that whole set unless you've done at least enough exploration to really understand it. And we've done that over the last couple of years. I think we're done. Like, I mean, we still got lots of work to do to find the answer, but we at least know the set of requirements to a certain extent. And that's kind of where, come on, mouse, hold on. Okay, that's what beyond the ampersand is sort of the round one, and then, yeah. So here's an example of some of the things. Alice, by the way, is working on some of these. This is where I wanted to have your name pop up, but I forgot to do it. Oh well. And other people as well. There's a lot of work going on here, and it's super exciting. And then, of course, we're also doing the just add async on this side. So what would that mean here, right? Well, here's our traits. The basic idea is, well, you're going to see, I guess. You write your traits in the same way. Here's a trait with an async function. Statically, this will work the same way. Remember, the key point is here in the static case, we know how much stack space. So you can just write .08. That's all you got to do. But at least the design that I am proposing, which I will add, I have not yet written the RFC, and I know that people will hate it. So probably it'll change before it gets out there. But this is what I think we should do, roughly speaking, is to have some way to say, at the call site, I'm going to box this future. So essentially, you're moving it and saying, when I call through a DIN, you're going to get an error message where the compiler is going to say, I don't know how big that is because I don't know what impl you're using. So please write .box so that I can box it and you can move on with your life. And there is a problem that Alice pointed out, and I don't want to forget that. But basically, this should work. And the key thing is that we're leaving space for what may come in the future, right? Because the idea here is to be somewhat explicit. It's kind of a current Rust constraint that we won't allocate memory without you having some visibility into the fact that it's happening, right? And so putting this dot box here helps us meet that constraint. And I think what I've noticed in this whole space is that there's been this conflict. Like on the one hand, you have people who are saying that constraint is inviolate, and on the other hand, you have people saying there is no way I should ever have to write dot box. Please don't make me think about that. And they're both right. But I think where I've come to over time, I've kind of lived on both sides and wrestled with this, is that we really do want to concentrate on this soul of Rust, at least as our default, which is like it's low level enough to use it in the kernel, but it's usable enough to put it in a GUI if you can tolerate some pain. You know, that's our sweet spot. People who can take a little pain. So, but I think this is really important. And actually, the reason I think this is so important is not just the fact that it would be nice. It would be nice if you could write a dynamic dispatch with a trait, but because it's blocking a whole lot of other stuff, like not having these language features is blocking us from building out the ecosystem and making it a lot better. And my go-to example is Tower. This is the Tower service trait as of 0.3. It's got a lot of stuff in it. I won't explain it all to you. Instead, I will show you what I think, well, I wish it could look like, and I think other people agree, which is basically simple and nice. It gives you the idea. It's an async function that says, hey, call me. Give me something and I'll give you something back. But you can't write this today because if the Tower trait were defined this way, it wouldn't be usable with din, which it must be. And it wouldn't handle send constraints, which I didn't talk about, but those are important too. And it has to, so in other words, it won't be able to be defined this way until at least some reasonable large set of users can actually use it for all the things they're supposed to use it for. And to get there, we have to do the just add async style plan, right? So we need this. We need to keep both sides so that we know we're meeting the requirements, and that will let us unblock the ecosystem. And I think that's really a good thing to do. But talking about the ecosystem, that brings us to sort of the next point, which is when I go and talk to people adopting Rust, especially the people who I would call the early majority style, I hear essentially two things. First, I hear this. Hey, Crates.io is awesome. It has so much cool stuff. And I'm like, yeah, I know, it's so cool. And then I hear this. Also, I don't know which one to use. And it's really stressful, and I don't know what to tell my employees. And I'm like, yeah, I know. So this has been something people have been saying for years, right? It's hard to navigate. It's hard to know what's the right thing to do. And sometimes there's like 3 alternatives, each of which is really quite good, but people can't get behind just one, and so they're all kind of unfunded. So when we started setting up the standard library, we intentionally made it very small, and we intentionally leaned into Cargo and Crates.io and so on, right? And the reason for that is partly what I was saying before, like the range of use cases we had to cover was pretty high, and we didn't want to accidentally rule them out. But also, there weren't only so many of us, in that central ecosystem, and we'd never be able to populate all the kinds of libraries and things we need single-handedly. Building out a standard library is a lot of work. So this let things get bootstrapped really, really quickly, right? And what we found is that's all really true. By opening the floodgates, like getting started with a new crate, Cargo publishing it is all pretty easy, and you can start to get users, and that's really cool, and I think that's really helped us fill this out. But what we're now finding, we're like past that honeymoon phase, right? And it's like, okay, well, also I have to maintain that for years. And now there's like business critical services running on it, and they're like sending me issues of things they want to change, and I don't know, this is not good. And I do get that. And this is getting even harder with things like the CRA and legal requirements, not to mention the AI stuff I talked about earlier. There's just a whole lot of pressure mounting, and I'm worried about it, So I think it's still true that I don't think we should have one standard library. People often who are adopting tell me we should. They say, look, Go is awesome, which it is. I love Go. I do love Go. I haven't actually written a lot of Go, but I think it's cool. But what I mean is they tell me I love the experience of Go because I just give it to my people, and they're off and running, and they know what to use. And I don't think we can quite do that and keep all the cool things about Rust. But I think we should be keeping that in mind as this is something that really works for people, right? There is this risk, which is very important, I think, which is actually picking winners is really hard, and it's really easy for that to go wrong if you're trying to sort of do it up front without really knowing. So like, this is the same sort of thing why we didn't want to build a standard library, right? Because What if we didn't do a good job? What if we didn't know everything we needed up front? And what if, then what would we do? We'd be stuck with it. So what much better is I think if you can sort of watch and see what plays out and then elevate the winners kind of that are merged by adoption rather than picking them up front. Right? So anyway, this comes that meme again. But like we're back to one of those things, oh God, we need a standard library, yeah, that would be useful. Or we need standard crates, but we also want a varied ecosystem with bubbly adoption and cool stuff like that. So here's another idea that I'm floating around. Some of us have been working on it lately. Probably a blog post coming soon. The idea is, let's try to have both. Let's try to have something called battery packs, which is basically like, well, we're not going to give you batteries included, but we are going to give you batteries. You can have some packs of standard batteries that you can plug in. So if you'd like to work on, say, an async ecosystem thing, we'll have perhaps a set of commonly used async crates. Or if you have CLI, you might have commonly used CLI crates. And you can actually try it now. We've got like a demo up. You can cargo install or binstall cargo BP, and then cargo BP LS will list all the battery crates. There aren't a ton of them right now, but you can try it out. Actually, I'm going to show it to you. Hold on. Here we go. Can you read it? No. You also can't see it. Wait. Oh, that's weird. Sorry, it's playing on my screen, but it's not playing on yours. Okay. Oh, it's tiny. All right, here's what I'm doing. I'm going to read it to you. I'm going to narrate it. I'm typing cargo BP LS. There's a list of battery packs. Oh, here's the CLI battery pack. How cool. I'm adding it to my project, and it's listing a bunch of handy CLI libraries. And then, and this is the interesting part, I'm looking at cargo TOML, and actually this looks different now ever since a CR that I have, or a PR I've almost pushed. But here what happened, those dependencies got added to my project, okay? So the thing I wanted to get across here is, whoa, stop playing, is that it's actually really useful. Like even I kind of knew what these libraries were, and already I was sort of like, oh, this is handy. Now I remember their names and I don't have to think so hard. But secondly, that it's not a thick abstraction or something else. It's just another way to add these crates to your crate and use them, right? So there's no giant adoption leap or anything you need to do. You're already using battery packs, whether you knew it or not, just by having crates. So Jess Eisen is here. She opened a really cool PR recently to show like this site, what I'm coming to see is this goes beyond just what libraries to use. It's also like how to learn certain common best practice in Rust. So we have now a CI battery pack that will set you up to publish binstall, run fuzzers, I don't know, various common things that when you go to someone's GitHub repo and you're like jealous of their CI setup, like I am, you're like, oh, how do they do all that cool stuff? You know, I can barely run cargo test. Well, now you can cheat this way and just do it. And you can even add it into your existing projects. So you might be wondering like, does this really change anything? Because one of the aspects of battery packs that I didn't mention, but I should have mentioned, is that anybody can make one. They're actually just a crate, right? They're a crate whose dependencies are your recommendations, basically, and the tool knows how to interpret them. So if anybody can make one, how does it actually help? Because aren't we back where we started? Now we'll have a bunch of competing battery packs? And the answer is, yeah, maybe. But I think that's a good thing. And it comes to the next step. It works hand in hand with this next idea, which is actually something that came out of the Rust Foundation, setting up the Rust Commercial Network, where the idea is we're going to get together the people who are using Rust and give them a space to collaborate. Because one thing we noticed is these conferences are great, and in between conferences, we need places where people who are using Rust can come and talk to one another about what they're doing and sort of learn what are the best practice and share ideas and so forth. And as part of that, what we would like to do is have some dedicated working groups that will be coming up with battery packs, right, among other things. And the idea is essentially, here's a bunch of Rust users saying, here are the crates we use. This isn't necessarily saying what you should use. That's kind of on you. But if you'd like to use the same things that we're using, we'll make it easy for you. And we'll contribute. Right now that we know what those things are, let's say there's 4 or 5 companies all relying on it, we can start to pool money and start to help the maintainers, start to contribute, add features, help them meet those requirements like the CRA and the other things that are coming, and help support the things that we're all depending on, right? So I think that's really cool. And so essentially the answer to the first question of how does this help is it lets us have some existing authorities. Let's have some reference points. I do anticipate there will be competing battery packs, and I think that's great. I think there will be like a network service battery pack for people running on servers, and at minimum, there should be an embedded one, right? Because the set of crates you use if you do hard embedded work are very different. You care a lot about binary size. That's just not important in other environments. And so I want these different battery packs that are tailored to specific environments. I think that's going to get the best out of Rust. And the ones that bubble up and get widely used, perhaps will come into the foundation. We'll make sure they're prominently mentioned, and so on. Okay, so, by the way, I didn't put this in, but I think like one of the things I'm trying to do here is take aim at all the things that we all know is a problem and has been a problem forever, and we haven't figured out how to solve it. And I don't know if I've actually cracked it with these ideas. Please tell me all the ways that they're broken. But I guess my meta theme is like, we do need to take these problems on sooner rather than later before we have the AI hordes at our door, right? And I think getting some way to recommend crates is one of those things. But the next problem is this maintenance story. It's been a challenge for a really long time. You all read XKCD, you know the comic. I don't have to tell it to you. What are we going to do about it? You know, and I think this is an area where the Rust Foundation can help. The Rust Foundation staff are very keen. They want to figure out ways to help support the Rust ecosystem, and I think the Rust project wants to help them too, because it's kind of something that we all need, right? And we're running up against a challenge we've been observing for a while, right? Coming back to this comic, which is, first off, the work of maintaining a task or a crate. There's a lot of work. It's often thankless. And I will say when I started at Amazon, or just like 5 years ago, I was kind of naive about this. I thought, I'm going to show these people in the industry how to run an open source team. I'm going to go in there. I'm going to change the world. Everyone's going to love it. I'm going to get lots of money. We're going to make these great things, or get lots of money, not for me, but for the ecosystem and so on. And to some extent, I feel like we've been successful. But also what I've observed is, boy, it's a lot easier when the economy is like growing 2x every year, as it was in 2021. It's a lot easier to raise that kind of money and get those kind of donations. When you start to have these contractions, it's a little harder. And we've seen, there's been some headlines, we've seen that Rust maintenance is one of the first things that tends to go, right? Because let's face it, if you don't need it, why would you pay for it? And so what we have to do, I think, is find ways to have a key, we have to align the incentives, right? We've got to be able to communicate what is the value, why does this make sense, and how can we sort of make it very easy and painless, right? As well as safe for you to do so. And so this is where I think the Rust Foundation is so important. This is where that Rust commercial network comes in. I think a key part of our pitch wants to be, there's a whole lot of stuff that we're all using, and we could all maintain it individually, but it's going to be a lot cheaper if we can pitch in, and we can do a better job. Because one thing that I think isn't always understood about open source is like the idea of, especially for something that is not your primary product, you're not really going to invest in improving it very much. So if you can have something where everyone's coming in with their set of needs and they're bringing them, it winds up being a better experience for your people as well, right? It's going to make you more productive. So what are some of the things we're doing to help this come to real life? One big one, the Rust Foundation Maintainer Fund. This was announced by the foundation some time back, and then on the open source side, we kind of got together and we pulled together an RFC, which is currently open, kind of describing how it's going to work, right? And the idea is to have maintainers and residents who are selected. The project will have a big hand. The Open Source Leadership Council will have a hand in sort of finding the areas of the project that are most in need of support, and direct those funds and try to help support the existing maintainers, basically, wherever possible, right? And I think this is a great thing. If any of you have budgets at your companies and would like to talk about how you can help support it, any of you on the internet watching this later, please get in touch. What this is going to do, if we're successful, is it's going to support the core Rust project, right? The tool chain and that kind of stuff. And I should mention, there are more efforts, and I think this is also great. The Rust NL maintainer team, for example, is pulling across a similar thing, but with a kind of team of maintainers working in very specific areas that have gotten together and are pooling their resources and also being supported. So we're starting to see this rise, where rather than funding individuals, which is very difficult and a lot of overhead, we're funding teams and groups and structures. I think that's the step we need to be making. And that brings us back to these roadmaps. Because one of the big challenges with funding maintenance is that it's hard to say what you're getting back for it, right? I made a pitch just now that was sort of like, hey, you're gonna pool your resources and you're gonna get a better results. And that's true, but also what you really want is to be able to say, here's a specific problem you have, and I'm gonna fix it for you, right? And so the idea of roadmaps is to say, let's let the project define. We kind of know what problems people have, and we kind of know how to fix them, but there hasn't been an easy way to connect the dots, right? I have this problem, how can I use money to make it get better? In fact, for years I've been at conferences and people will come and say, I want custom allocators, what can I do? And I say, I don't know. You can go read a GitHub issue, I guess. That's not really a good answer, and it has not resulted in a lot of money coming into the project as it happens, or funding the people trying to do the work. So the idea of the roadmaps is more like, here are some problems, here's some of the plans we have to attack them. We will try to coordinate and raise money to attack those problems. We'll use that to make sure we fund both the maintenance that is needed to do the reviews and the other work that enables this stuff, and to support that actual work getting done where needed. And so that is half of it. And then the other half is, these are the ones I know about. I want to hear from companies that want to drive work forward, right? Maybe you have a roadmap, I think, that you would like to see going on. Maybe you're upset. For example, the compilation time isn't on here. I am. We should come together and try to make a plan that will address that need, or work with the people in the project, come up with what is the set of goals we need to do, and make it happen. So, all right. Thank you very much. It's been a real pleasure speaking. Thank you to all the organizers of this conference. It's been super fun. And thank you to all the people who made Tokyo a reality also, I should say. These are the three things I want to leave you with. 3 big hard problems. I think we have some ideas for how to address them. I'd love to hear your thoughts on where I'm right and where I'm wrong. And of course, this one. You should go watch this movie. It's funny. I want to push it to the next generation. Thanks a lot.